So we're going to talk about chapter 3. In this chapter we cover water, pHs,
and that's it.
Yeah, sure.
Heat capacity is a part of water, stupid.
Fine. Heat capacity is a part of water. So first we look at pH. So pH ranges from a scale of 1 to 14. 1 being acidic, and 14 being highly basic. So highly acidic, highly basic, and 7 is neutral. One of the common compounds or elements or whatever that are neutral is water. So that's usually where we start off with a pH of 7.
pH is the concentration of hydrogen ions. Thank you very much.
There you go. pH is concentration of hydrogen ions. If you go more into chemistry, you know that there's both hydronium and hydroxide ions, and that's how you distinguish between acidic and basic. So highly acidic acids are characterized by being bitter, reactive, and corrosive because they have that characteristic to them. And then bases are more slippery, sour, and non-reactive. And I guess I am complex and I have not reached my full potential. So basically the pHs tell you like how the compound will react. So you should look up for that.
Wait, so acids react more or less?
More.
And basics?
Less. But that's not true. Because if a compound is highly basic...
This isn't chemistry.
Okay, fine, whatever. So all you need to know is 1 to 14, 7 being neutral, and then these are like the characteristics, acidic and basic. Moving on. Water is a solvent, and it's it's the most universal solvent. It's not up here, but it's H2O, dihydrogen monoxide. It's a solvent is polar substances that dissolve, and I guess are ionic.
They dissolve ionic bonds. That's what's in the yellow book.
Yeah, okay. Well then, a solvent like dissolves like. So that means that a polar solvent would dissolve a polar, and a nonpolar would dissolve a nonpolar. So a hydrophilic solvent likes water, whereas a hydrophobic hates water, because a phobic is like a phobia. So
and hydrophobic is nonpolar.
Yeah, hydrophobic is nonpolar.
You suck at explaining.
You suck at writing everything on here.
It's because you're not supposed to write everything. You're supposed to say it.
I guess.
Hey, look at my ice cubes. And Simeon's nasty cupcake.
Definitely not an ice cube anymore.
You're mean. Okay, go on. Water expands.
Okay, water expands when it freezes and becomes less dense, like
which
an ice cube.
is unlike normal substances. Normal substances contract and become more dense.
Yeah. So
that's why water's special.
So yeah, so like when water freezes, what happens is the particles themselves go farther apart, and so the amount of surface area that it covers allows it to be less dense, and so it'll float on top of regular
ugly
liquid water.
cupcake. Beautiful cupcake.
Okay, back to what we're learning. Then when we talk about water, we also talk about adhesion and cohesion. Cohesion is the attraction between like substances. And it happens because of hydrogen bonding in H2O, and it causes high surface tension. Surface tension is a strong surface which is firm, allowing insects to walk across without sinking. Originally drew a person.
It was not a person.
A person cannot walk on water, so yeah, it's like an insect. Because there's those certain insects that can, like when they walk, they can go really fast across the water, so they can walk on water. Adhesion is the attraction between non-like substances, which causes capillary action, which adheres to walls of substances. So like if you're thinking about like water in a test tube or something, you can see like the meniscus, right? Like if you have a test tube, and
that's a fat test tube.
Shut up. And you have water. Like the fact that water sticks onto the sides like this is adhesion, where then when you record how much water is in it, you do the bottom of the thing because adhesion, or the bottom of the meniscus, because adhesion causes water to stick to the sides, and that plays a role in like water uptake and stuff like that. Moving on. So that's basically water as a form of solvent, cohesion, adhesion, and expanding.
And it has heat capacity.
So So now we're getting to heat capacity.
Look at Simeon's ugly writing.
So this is the degree to which a substance changes temperature in response to gaining/losing heat. When we look at water, water has a high heat capacity, and UP is yawning because she's very tired. It changes temperature very slowly because if you think about it, a large body of water changes temperature very slowly in response to changing outside air, because it takes so much longer for water to absorb all of that energy or give it off. So a large amount of heat must be required to change temperature, whether that's boiling or freezing. These are a bunch of smiley faces, which means that we're at the end of this chapter, which makes Yuki very happy because it took us an hour to do this whole board.
No, it took us like 10 minutes.
No.
It took me 10 minutes to do that much, and then it took you an hour to do that.
Yes, because I was not very cooperative.
He's procrastinating.
Not
okay,
procrastinating.
Overview. pH, water properties, adhesion, cohesion, water expands, it's a solvent, surface tension, capillary action, and heat capacity.